Hello everyone. Today, in this new video, we're gonna talk about aldehydes and ethers. The physical properties of aldehydes and ethers are almost the same when being at room temperature. When being at room temperature, the states of matter or the state of matter of these two, it's a liquid state of matter. The only exception here is when there's a formaldehyde, that this is and has a gas state of matter. In this next picture, you can see more about of the physical properties of ethers, where you can see that the melting point and boiling point of all the ethers change depending the element. As you can see, the dimethyl ether has a melting point of minus 140 and a boiling point of minus 25. And on the other hand, for talking about the aldehyde's physical properties, you can see that the boiling point and melting point also varies depending of the element. On the propanol, you can see that the boiling point is 48.8 and the melting point is minus 81 degrees Celsius. For talking about chemical properties of aldehydes and ethers, I'm going to start saying some of them of ethers. Ethers are non-reactive. That's why they are used as solvents for a lot of reactions. Also, ethers are very flammable and they can produce explosive mixtures when they evaporate and mix with air. Another chemical property of ethers is that they aren't malleable. This means that they aren't able to shape or change their shape to another form like other elements. Now, for talking about aldehydes, we can say that the only difference in their chemical properties is that aldehydes are extremely reactive, in difference than ethers. But aldehydes also are very flammable and can't be shaped and aren't malleable, just like ethers. For talking about the atomic properties of these two, I'm going to start talking about aldehydes. Aldehydes are organic compounds where the carbon atom in the middle shares a double bond with an oxygen atom, a single bond with a hydrogen atom, and a single bond with another atom that is represented with the letter R. Now, for talking about ethers, we know that they are also organic compounds, but they contain oxygen atoms bonded to two same or different alkyl or aryl groups, that in this case they are represented with the letter R. Now, in this part of the video, I'm gonna teach you step by step how to name the IUPAC nomenclature for each of the aldehydes and ethers. For naming ethers, our first step is to know that ethers are compounds that have two alkyl or aryl groups bonded to an oxygen atom, as we see in the previous formula. The ether functional group does not have a characteristic IUPAC nomenclature suffix, so it is necessary to designate it as a substituent. Then, to do this, the second step requires you to note that the common alkoxy substituents are given names derived from the alkyl component, as you can see in the picture that is showing your screen. Now that you have these examples on your screen and after knowing this, your third step will be to know that ethers can be named by naming each of the two carbon groups as a separate word, followed by a space and the word ether. And remember that the OR group can also be named as a substituent using the group name alkox. By knowing this, you will be able to name ethers in their IUPAC nomenclature very easy. And for proceeding with the video, now that you know how to name ethers in IUPAC nomenclature, I'm going to advance and teach you how to name aldehydes in IUPAC nomenclature. Your first step will be to determine the longest carbon chain that contains the aldehyde group. Then your second step is to change the E ending on the alkane name to Al. Your third step is to add in a prefix to identify where the aldehyde is on the carbon chain. You can do this step by counting the carbons in the parent alkane and finding the number that gives the aldehyde the lowest number. For finishing, your fourth and last step is to add in any substituents by adding the number carbon they are attached to with their prefix from the chart that you can see on the screen right now. And list all substituents in alphabetical order prior to naming the aldehyde. For you to have a better idea and understanding, here are some examples from a UPAC named aldehyde elements. And in here, you can see an example of a UPAC named elements, but in this case, from ethers. Now I'm going to tell you some uses and applications of aldehydes and ethers. For starting with aldehydes, we can start saying that aldehydes are used by chemists daily to synthesize other compounds. This is the major use of aldehydes, but some types of aldehydes, like formaldehydes, are also used in the world for tanning, preserving and embalming, and as germicide, fungicide and insecticide for plants and vegetables. Another fact about aldehydes is that they are a group that occur from natural products like a cinnamon bark and vanilla beans. Ethers have a lot of uses that we don't hear too much about. Ethers are used as solvents for fat, oils, waxes, perfumes, and resins. They are also used as refrigerants and to start a diesel or petrol engine. Ethers are also used in hospitals as anesthetics and disinfectants, and ethers are organic compounds, which means they are natural. With all this said, I hope you have learned a lot more about ethers and aldehydes. We will see you in the next video. Bye!